Hello guys, this is Razor Game Dev, and welcome back to another episode in Let's Make an Adventure Game in Love2D. So, today, I'm going to be working on making a physics engine for the game, so we can get a player moving around and stuff. I've been kind of bored with just what we've been doing so far. Actually, let me change the color theme. I kind of want to do something a little bit new. Let's do Mononoke. Yeah, it's one of my favorites. Okay, so... yeah, physics engine. So Love2D does have a built-in physics engine, but it's not very precise. It's accurate to like real-world physics and stuff, but it's not very precise, as in pure pixel snapping and all that. And it's just a little overkill for what we need right now. What we need is just a very simple physics engine that does collision, maybe some like velocity and deceleration and stuff like that. So yeah. So that's what we're going to do today. Let's close a lot of these scripts up and let us make a new component. This is going to be our physics component. So C physics.lua. I'm just going to borrow the body. I'm just going to borrow this code right here and then change it to what we need it to be. So let's go Control D, C physics. Just like that. And let's make sure we lowercase this right here. C physics. Let's make sure that we change the name, physics. Alright. So actually, we don't really need any of this. Besides, we need to make sure that the, let's assert e.position. Just to make sure that we have a body component. Okay. So now we don't actually have to add anything in here. We're going to make a brand new module, and this is going to be our physics engine. So let's just name it physics engine.lua. Let's go into the main, let's require it. Just name it physics. Let's do modules, physics, engine. Just like that. Alright, let's create the module. And let's make an init function. Let's make a add body, and then let's make a tick, or let's make an update. So okay, and actually let's add a renderer too. Debug render. That's gonna be useful for drawing our physics shapes and all that. So at the very top, let's do self.bodies. Make that equal to the table. Let's add ourselves to the game loop. Alright. Right here we're going to pass in an entity and then some parameters. Let's do settings. Alright. So let's go into the main and let's actually initialize and all that. Alright, I'm back. Sorry, I just got interrupted. Okay, so let's initialize the physics engine. So game.physics init. And that should do everything for us. For now, let's go up to the very top. Let's go up to the very top. And I'm going to make a global. Debug. Debug. Let's set it equal to true. Actually, why don't we use our settings? That way we can turn it on and off live. We can remove all this code that we don't really need right here. Let's do is debug. Let's make it equal to false for right now. Let's go into main. Down here. Let's go over here. If what do we name it? s.code.isDebug. Then we're going to say game.physicsEngine debug draw. Just like that. Let's go back to our physics engine, and I'm just going to print delta time just to see if this is working. Let's open up our command prompt. Let's go to our documents. Let's go into our project folder, and let's run this project. Okay, so attempt to call method draw main 53. Gotcha. Let's remove that. Okay, let's run it here. Okay, sweet. So we got our physics engine running. Okay, so up at the very top, in level actually, when we create the player. Sorry for the background noise, by the way. There's some construction stuff like that. Hopefully it's not too loud. E, add, require, components, C, physics, dot new. And then this is where the arguments are, this is where our settings are going to be. So in our C physics, right here we're going to say game.physics, add, body, E, and then we're going to pass in args. Just pass it through, like that. Let's build, and we're all set. Okay, so, physics engine. Let's think. So up here we want to initialize our entity to have physics. So let's give our entity some parameters, or some, I don't know, parameters, yeah. Velocity. So I have this thing called utils. This is my standard Lua utils file that I use for all my projects. It's quite small. It's only a couple hundred lines, like less than 200 lines. And we're going to be using this vector right here, this vector class. So let's go to physics engine. As you can see, it just has an x, y. There's an add, multiply, divide, get the length, normalize it. Or you know what? I kind of want to have more control over it. So we're going to say x is equal to, well, let's do it like this. Or let's do settings dot x or 0. So if we pass in a, or velocity x. So we can start it off with the initial velocity, which will make it like a bullet, for instance. You want to have initial velocity or 0. Entity dot friction is equal to settings dot friction or 0.95 probably. That sounds about good. Entity dot direction. We're gonna make that equal to 0. Function. We're just gonna add some functions too. So entity get direction, and this will return a direction in radians. So let's actually specify that. Rad. And then maybe we can get a get function or get. Well, let's always make this in degree. Let's make this return this in degrees. So let's do math dot degree. We're gonna say math dot atan 2. We're gonna say entity dot position dot x dot y minus entity velocity dot y, and then we're gonna do the same thing for x. And this should give us a direction that the entity is moving according to its velocity. If I did that correctly. I believe I did. One thing we want to do is at the very top is localize these global variables, especially since we're going to be calling this every frame. So degree is going to be math.deg. And it's actually, yeah, it's faster to index local variables because it's closer to the top of the memory stack, whereas globals are towards the very bottom of the scope, so it has to iterate through all the other variables to actually find it. So let's just call it degree atan2, and I'm going to one-line this, just like that. Alright, let's do entity, apply velocity, we're going to do a speed, and then a direction. This would be a direction in, well, let me think, should be a direction in degrees, I believe. And we're going to say self.velocity.x is equal to cosine, which we're going to have to localize up here. Local cosine is equal to math.cos. Local sine is equal to math.sine. Okay, so we're going to call it cosine of direction times speed. Whoops. Okay, let's just, there we go. Next, y is just going to be cosine, or sine, rather, of direction and speed. Okay, entity, let's think, what else would we want? So we can apply velocity to a certain, and I believe that direction has to be in radians, which, by the way, radians are just another way to measure degrees, I guess. Another way to measure an angle around a circle. You can think of it as Fahrenheit versus Celsius, kinda. Radians basically measure it in according to pi instead of degrees, which is, you know, a segment of a 360-degree circle. Okay, so I think that's all we need for now. For now, yeah. So up at the very top here, well, let's think. Okay, let's do this. Update velocity. Let's just do an update velocity, pass in delta time. We're gonna say, well, let's do update body. We're gonna say self dot position dot x is equal to no. We're gonna do this differently. We're gonna create a function up here. Physics engine, create body, position, size. So this is going to return a just a plain table with a position and size. Let's do create. Yeah, create body. No, that's a little misleading. Let's do create rect. Position is equal to position, size is equal to size. I'm gonna go and make a function here. Let's do intersects with other. Right. So we want to be able to create a body, just a rectangle that has an intersection function. So let's go to entity, or let's go to body in the entity right here, because we have this function right here, and I don't want to rewrite this. We can use this very nicely. Okay, let's go to physics engine, right in here. We want to change this to just pose. I'm going to change this just to plain old size, without a capital. And then E2 needs to be changed to other. Boom. That should work for us, I imagine. Cool. Okay, so we want to, instead of update body, I'm going to do function entity get x body. We're going to return game physics create rectangle. In here we're going to say self.position. Oh, let's actually create a table. X is equal to self.position.x plus self velocity. We need pass in delta time. Velocity x times dt. Then we're going to say y is equal to self.position.y. So what this is doing is it's basically splitting the x and y velocity vectors. Right? It's creating we're going to create two bodies, one for the y velocity and one for the x velocity, so that we can handle them separately. If we handle them at the same time, we're going to have bad results, so we have to handle them separately. This is just going to be self.position. Let's cut this, move this over here, change this to a y, and we should be set. Alright, so up here, let's get the two bodies. Well, let's create a body. No, wait, we have to update. Okay, let's loop through all the bodies. Okay, just gonna use a simple iPairs loop. Not the fastest, but whatever. I mean, should be fine for what we need. Local v body is equal to self create rectangle body dot. Did I do this right? This just needs to be size. I don't know why I said size.y. That just needs to be size. Yeah, so let's do body.position, body.size. Okay, now local x body is equal to body get x body. Local y body is equal to body get y body. Next, we're going to say body.position.x is equal to x body dot position dot x body dot position dot y is equal to y body dot position dot y. Alright, so what did we just do? So we created the two bodies with our velocity vectors. Up here we're gonna check for intersections between the bodies and like other bodies. And if we intersect, then we're gonna subtract the velocity from the y body and then reset it. So now let's see. Let's just build it and fix some bugs. So 29. Okay, let's go to 29. Settings is a null value. Let's go to physics. Args. Args should not be null. Let's go over to here. Oh, it didn't even print? This is strange. Let's just say friction's equal to... No, we shouldn't have to add anything here. Require the physics. See physics. Let's just print that. Okay, so that's really strange. For some reason, this isn't printing. At least it doesn't look like it. Oh, it is. It is printing. Okay, so it's printing a table, so that should be fine. Physics engine. Settings. Add body settings. So why does settings null? Let me see. What is the actual error? 29. Physics engine 29. Attempt index, global settings, a null value. 29. Oh, right here. I'm gonna print the table. And this function. Let's see if I can go to this. No, I can't go to the definition. Just a second. Alright, I'm back, guys. Sorry, interrupted again. It's a really stupid error. I spotted it. It's right here. It's supposed to be settings. That's really funny. And same here. Setting. It needs to be settings. Okay, so we're back in the game. Back in the game. So let's go over to a player. Or actually, one thing we want to do is decelerate the entity. So let's create a function. Decel. Let's call it decel. Sure. And for now, I'm not going to be using dt with this. We really should be, but for now, just for simplicity's sake, we're not going to be. Is equal to self velocity dot x times self friction. Let's do the same thing for the y velocity. Build it. All right. Make sure we're running. Down here, I want to say body decelerate. Cell. Again, we're still fine. Let's go to player. Let's add some, there should be I thought there was, level. Okay, so we need to make a new component, and this is going to be a player component. A player controller. Oh, what did I do? Excuse me. C player.lua. And here, let's go to the physics, because I think that's the physics component. Let's copy that. Let's go to player. So that's the smallest file so far. And then let's edit this. C player. Make sure to lowercase this. Oop, nope, too many. 1, 2, 3. C player. Okay, in the init, we don't really need anything yet. Let's go to the update. E, and then DT. Let's get some keyboard controls. Let's get some keys. Love.keyboard.is down, left, then, or let's actually do right. I always start off with left because I'm left-handed and that's just how I think. E.apply velocity. This is the direction. No, this is the speed. Let me go to the physics. Where are we? I passed it. Yeah, speed and then the direction. Okay, so speed, let's just do, I don't know, 25. And then direction, let's do math.rad. So we're going to convert this to radians, and we're going to do right would be 0, I believe. Let's make sure we go to the level and actually add that component. Let's build it. Okay, so I'm pressing the button and nothing's happening. And I think I know why. Oh, wait, maybe not, because I think we did call it. Oh, let's go to player and just see if this is registering. Okay, let's make sure we use this command prompt. So it is registering. Did you guys see it moving at all? Okay. Let's go to physics. That should be right. Oh my goodness. There we go. Okay, let's just print the print body.velocity.x. Let's just see what this is at. It's printing hello. Okay, so we're clearly not, oh, we're not adding the body to the table, huh? Okay, let's remove this print. Let's go to physics. So we gotta remember to put the body in the table. Oh man. Sorry, I got something in my eye. Let's do entity. Okay, physics engine 44. Oh, we need to pass in DT, of course. Whoop. Whoop. Get my key bindings mixed up from Visual Studio. 76. Woo! Okay, so this is pose. Again, key bindings. Okay, so you can see what we're moving, and we're slowly decelerating. So we can actually increase our deceleration. So let's go to, or increase our friction. And we might want to make the friction according to whatever tile he's on, but that's in the future. So let's go to level. Why can I not type in level? Okay, let's do friction is equal to, alright, so if we want to lower the friction, let's do 0.9. See what that's at. That's kind of nice, but let's do 0.85. That's pretty good. Okay, so let's go to the player. Let's add the rest of the controls. I like that. Alright. Let's do left. Let's do up. Then let's do down. Okay. So left would be 180. Up would be 90. This would be 270. And I got that backwards. This should be 90. And this should be 270. Okay, if we build, we got player movement. It looks like we can't hold down more than one key at the same time to go diagonal. I guess that's kind of like in Zelda, but I don't really know if I like that. I wonder why that's the case. Let's go to the physics engine and see what's going on. Oh, I think I know why. Physics engine, that's it. We want to, when we say apply velocity, we want to say self.velocity is equal to self.velocity x. Actually, why don't we do this to save some time? Alright, and then up here we're going to say x is equal, plus this. Y plus this. There we go. So now we got something that's kind of moving around. It's a little fast. Let's go to player. Let's turn down the speed. Actually, we should really not hard code this. Let's say self dot or e dot speed is equal to. Let's make that equal to 5. E dot speed. Multiple cursors are so efficient. I love it. Okay, so that's a little bit more reasonable speed. I believe, yeah, the player should be clamped to a velocity because of the friction multiplier. We got it moving. It's very smooth. As you can see, he snaps perfectly to pixel too. And that is intentional. So it looks a little janky, but, you know, for a Game Boy game, that's actually what you want. You don't want any half pixels. But yeah, I think that'll be very nice. Sweet! So he does feel like there's a little bit of, like, weight to him, which I actually really like. Okay, so, what we want to do now, so we want to add physics body, like solids, right? Okay, so, like solids like walls, so you won't be able to go through walls. We want to actually add those from the tile map here. Okay, so one thing we want to do. In Physics Engine, we want to add physics types. We want to have multiple different types of physics. So let's do entity.physics type. And the types are going to be settings. Well, we're going to say settings.type. Or the default is going to be dynamic. Now, there is another physics type, and that's going to be static. Static doesn't have any velocity. It's not going to have any physical, like, it's not going to be able to move. You're not going to be able to push it. It's going to be a static body. And we're going to say physics engine add static body. We're just going to pass in a rectangle. And then the settings for it. Alright. So we're going to say self table insert self.bodies. And we're going to insert a table. It's going to have the physics type of settings. Or let's just do static. I don't even think we need to add settings. Maybe in the future. We're going to say position is equal to rect.position. Size is equal to rect size. And I think that is all we need. Yeah. Yeah, I think that's all we need. Okay, so we're going to make another table up here, and these are going to be for statics. Alright, and we're going to say self.bodies. No, we're going to say statics. Insert this table. Alright, ah man, I keep doing that. I hate that. Okay, so let's loop through all the statics and see if we can collide with any of them. J static in I pairs self statics. Now this isn't very efficient because we're looping through every single static, every single body, like body iteration. But I mean, if we're not gonna have too many statics, not too many entities, this should be fine. And even if we do, like, still, this should be fine. Like, we can do several things to improve this by, you know, creating like sim regions and stuff like that. But for now, this is fine. This is okay. Okay, so we want to create a body. Static body is equal to self create rectangle, and this is going to be static dot position static dot size. All right. With that, we want to also say we're going to check if the X body collides with it. So X body collision, then Y body collision. Just like that. Okay, now we want to say if static body intersect with X body. So if we collide with them on the X axis, we're going to say X body dot position is equal dot X is equal to V body dot position dot X, and we're going to do the same for Y. So this resets, this reduces the, oh no, not reduces, what am I trying to say? This gets rid of the velocity that's applied to the body here, so that the body will stay in place. Let's make sure we make that Y, and this Y. So in level, let's just create a simple static. Actually, let's go to the physics engine, and let's render all our statics. Create a little I pairs loop. Let's go self statics let's do love.graphics.set color. Let's do 255 0 0, and let's reset the color. Oh my goodness. Graphics. Let's see. Set color right here. I'm going to set the color to 255, 255, 255. Here we're going to say love.graphics, draw rect. So rectangle. We're going to say static.position.x, static position.y, static.position or size.x, static.size.y. Just like that. Let's build this, make sure we're all good. Let's go to 82, see what the heck's going on. Statics, I think it's statics, isn't it? Sweet. Alright. So, let's go to settings and let's turn on debug. So make sure we don't have any errors there. Whoa, opened up a new instance of Visual Studio Code by accident. Debug draw and nil value. What did I name it? Debug render. Ah. Okay, let's go to main. Let's change that. Nope, not what I'm trying to do here. Oh, it's right here. Okay. Just like that. Okay. Build, we're all good. Okay, let's go to level and let's create a simple shape. Create static body. Then we need to pass in a rectangle. Let's see what the rectangle, I think it's a position and size. So position. Go to this, x is equal to 0, y is equal to 0. Alright, size is equal to this, x is equal to, let's do 50. No, it's too big. 25, y is equal to, let's do 50. Okay, what do we name it? Physics engine. Add static body, dir. Okay, let's do that. In invalid draw mode, we need to go to physics body. Oop. Nope, wrong one. Physics engine. Let's go to line 100 or so. We need to add, we're going to say line. This is just drawing a line around the static body. Okay, and we're not resetting it apparently. That's really strange, but... Oh. Okay, so we need to make this a little bit... Oh, you know what? This isn't being... We want this to be in our canvas. Yeah, there we go. So if we collide with them, 92, we have an error. So physics world, 92. What's going on? Why is that an error? This is pause. I think. 87. This is pause too. I really need to make this different. Okay, so as you can see, I'm moving left right now. Moving left, I can't collide with it. I'm moving up, can't collide with it. And it's very nice. It's very accurate, right? I'm really confused why this isn't updating the color or change the color back. Maybe I need to do that. No. Love graphics set color. Let's do this at the very top here. Let's just always reset the color. Let's unindent that set color. Oh my goodness. Let's do 255, 255, 255, 255. I think it has something to do with the canvas. Yeah, I don't know. That's strange. That's really strange. Well, anyway, you can see that there's this physics wall right here, and it works really well. And next time when we have more entities, we'll be able to collide with entities. But I'm not too worried. Actually, before we go, let's go up to the very top, near the very top at least. Up here, we want to create another function, and this is going to be a callback. Alright, so we're going to have to handle this. So we're going to say entity collision other. and we're not actually going to handle it right there. But yeah, once we collide with other entities, we can do stuff like apply physics to ourselves, apply physics to others, so we can push things around. We can do quite a bit of stuff right now, and I think this is really good. This is a good start. We got well, what's my time looking like? Yeah, this video is pretty long. Anyway, so next time we'll also add, we'll make it so we can draw solids in the tile map and then add it to the map right here, so that we can edit it from tiled and all that. But anyway, guys, thanks for watching. Hope you enjoyed. I hope you learned something new. Be sure to check this out on GitHub. Let's actually add or commit the changes up here. Added simple physics engine. There we go, we just committed the changes, so everything should be updated on our GitHub account. Anyway guys, thanks for watching, and I'll see you in the next video. Peace out.